Hi, I'm Professor Pi, and today I'd like to talk about how I drove to school. Is it a function? According to our vertical line test, it would be a function because I didn't go down any street twice. I came straight to school, but did I drive 30 the entire way? No, it wasn't constant function. Did I drive 60 the entire way? No. Once you get out front, there's speed limit signs. Once you get up on the main street, there are speed limit signs. And when you get closer to the school, the speed limit goes down. So part of my way on to school, I was driving 55 or 60. Part of it, I was driving 45. Part of it, I was driving 30. And part of it, I was driving 20. How I drove to school was a piecewise function. Part of it at one speed, part of it at another. I made several turns. My line comes straight from my house to school. It doesn't cross any streets twice, so it is a function. Although it's a very complicated function, I probably went 3 or 4 different speeds. This is called a piecewise function. The I can statements, I can interpret and graph piecewise functions. I can define and graph step functions. I can define and graph the greatest integer functions. My video will go here. You've got 4 others, 5 others. If you need them, go to them. A piecewise function is a function that's in pieces. The graph of any piecewise function might look like 3 or more graphs put together. This one I have in 3 colors to distinguish the 3 function parts. There's a blue function part till you get to -1. From -1 to 1, there's a red function part. Looks like a straight line. And when you get above 1, it has another function, the green. For example, our function may have a y range when x is less than 3, and then a different y range when x is between 3 and 10, and a different y range again when x is above 10. We will put my sample function into large brackets to indicate that it's one function. F of x, or y, is over here. My 3 functions are here. Now I'm actually going to construct a graph, a t-graph with xy points in there. And I've separated the 3 functions. Here's function A, B, C will be down the screen. When x is less than 3, we have y equals minus x minus 4. So 0 minus 4 is -4. -1 minus 4 would be -5. -2 minus 4 would be -6. Then when we get to 3, we're going to have a different function. Our function here between 3 and 10 is y equals x squared subtract 7. So I'm going to square my number and subtract 7. 3 times 3 is 9, subtract 7 is 2. 4 times 4 is 16, subtract 7 is 9. 5 times 5 is 25, subtract 7 and we get 18. 6 times 6, subtract 7 is 36, subtract 7 is 29. 7 times 7, subtract 7 is 49, subtract 7, it's 42. And 8 times 8 is 64, subtract 7 is 57. Nine times 9, then subtract 7, that's 81, subtract 7 is 74. And 10 times 10 is 100, subtract 7 is 93. And then after x is greater than 10, we have a new function, a C part. Y is equal to 120 divided by X plus 5. (11) 120 divided by 11 plus 5 is equal to 15.9. 120 divided by 12 is 10. And 10 plus 5 would be 15. And 120 divided by 13 plus 5 is equal to 14.2. And I don't care to graph that function, but it would be very easy to plot these 3 points, draw a line between them, plot these points between 3 and 10, plot the points between 3 and 10, and draw a line between them. And then up here, but we would plot the points between 0 and 3, draw those points, and draw a line between them, and we would have 3 lines on our graph. And if we did it in different colors, it would look like this one up here. A step function makes steps up or down. One step function is called a rectangular function or a boxcar function. Here's our function. Does it look like steps? We got step here, then we step up here, then we step down here, and it's a step function. Basically, below this point, we have a straight line. Above this point, we have a straight line. We have 2 dots to make the function continuous. And then we have a stair up there. One example of this type of function would be when x is less than 0, we go to 2. When x is equal to 0, we go to 2.5. And when x is greater than 0, we go to 3. This would be a step up function. It would look like one set of stairs. 2, a dot at 2.5, and then another stair at 3. Another example of a piecewise function is the greatest integer function. We use square brackets for absolute value. Notice these aren't square. These aren't straight brackets. I'm putting the x in a square. So y is here is defined as the value of x such that the largest integer less than x or equal to x. So you round down basically. 2.5 goes to 2, 3.9 goes to 3, 3.1 goes to 3, and 2, of course, is equal to 2. So 2 would be on our graph. And what this does is it looks like a step function. It's a greatest integer function. It's a step function. Each step's only one number. This is a step between 1 and 2. This is a step between 2 and 3, 4 and 5. And this could go on infinitely longer. The greatest integer function, you could always round down no matter how high a number you got. 3,412.3 would round down to 3,512. Those are some examples of a step function. Your assignment's down here at the bottom. Please have a nice day in your math class. At the end, there's going to be an exit ticket, and you can show me what you've learned.